In this video, we are going to work through these three problems, finding area of regions, um, and we're going to use a graphing calculator. So the first one is, and they all kind of hit different ideas, and I'll show you lots and lots of tricks with your calculator. So please make sure that you have a graphing calculator with you. The software online is also free for 90 days if you want to download it from Texas Instruments. I'm using a TI-84. So let's do the first one. I will just scroll here. The first thing I'm going to do is plug this into my calculator. So 5 minus x squared and x cubed, or x squared minus 3. So to do that, I'm going to go to the y equals screen. One thing you should always check if you're doing the AP curriculum is make sure that you are in radian mode right there, not in degree. But I'm going to go to my y equals screen. I'm going to type 5 minus x added to the second, and then x added to the second plus or minus 3. So the first thing I'm going to do is do a zoom 6. I always try a zoom 6 first when I'm graphing things, unless I have other contextual clues. And I don't here, so I'm going to hit zoom 6. Boom and boom. So this gives me a pretty good window. I'm not going to change the window for this one. You can see that the graphs hit each other here and here. It looks to me like it's -2 and 2, but I'm going to check anyway. So I'm going to go second. I'm going to hit the trace button. I always say second calc because it's the calculate. And then I'm going to go down to intersect, which is number 5. And notice here, with the color version, I can see very clearly which one is being highlighted. It's going to ask me first curve, second curve, and to guess. So I do want my first curve to be y1, that blue one, so I'm going to hit enter. I want my second curve to be the red one, so I'm going to again hit enter. And now it wants a guess. Currently, it appears that I'm halfway between those two. So I'm going to scroll over to the left a little bit and make sure that it gets that one over there. I guess I could go one more. Enter. And then it tells me the intersection is -2. Okay, that's good. I know that the first intersection is 2. Now I'm going to repeat that for the other intersection. Second calc, 5, first curve, second curve. Oh, and then here, let me show you a trick. I'm going to guess at 2. So when this guess, I can use the arrows to go back and forth, or I can just type a number. I can type 2, and it'll take x equals 2, and I can hit enter. And then it says, all right, yes, you're correct. So it saves all those clicks to move left and right. So I'm going to flip back to here. This area is going to be calculated by the integral from -2 to 2. I always like to think of top minus bottom dx. So what do I mean by top minus bottom? I need to figure out which one of these equations up here is the top and which one's the bottom. So let's go back to the graph. You may be able to tell, but I'm going to just double check here. I'm going to hit trace, and I'm going to scroll over a little bit. I'm clearly on this upper blue one. Notice it tells me that's y1. And if I hit down, it'll take me to y2, which is x squared minus 3. So you should see that the top is 5 minus x squared, and the bottom is x squared minus 3, and I can use the calculator to figure that out. So come back here. This one is y1, it is the top. This one is y2, it is the bottom. So I'm going to do the integral from -2 to 2 of 5 minus x squared minus x squared minus 3 dx. This first set of parentheses that I wrote is actually not necessary, but the second one absolutely is, because this negative needs to apply to both those pieces. Now, we could calculate this integral by hand. It's not that bad, but I'm going to show you how to do it with your calculator. one thing I want you to notice is that this is the integral from -2 to 2 of y1 minus y2. I'm using the y1, y2 notation that I have up here, and that matches what I have in my calculator, dx. So what I'm going to show you in the calculator is that I can actually type this into the main screen and it'll do all the work for me. So here we are again with the calculator. What I'm going to do is quit out of here. I'm going to use math, and I'm going to use fnint. It's always math 9. I'm going to go -2, enter. Oops. This is actually perfect. A lot of times people get errors and they're like, what do I do? Everyone always quits when they get errors. Instead, do a go to, and it'll take you to the spot that it has an error. So this one isn't actually the best example of that. It's saying there's nothing in there, and it can't calculate the integral. It also can't calculate because of those two. So let me come up here. I'm going to hit a 2, and then I'm going to go arrow. And here, this is new for you, I think. You can pull up y1 and y2 in your calculator very easily. Especially with these newer calculators, it's even easier than it was before. If you hit the alpha button and the trace button, notice all of your y's come up. So I can just select y1, enter, minus alpha trace select 2, and then I'm integrating with respect to x. This variable needs to match the variable that is used in that y equals screen. I hit enter, and I get this. Now, say I'm on a multiple choice test, and the answer is in fraction form. And I, what's 21.333 as a fraction? I know it's like a third, but how many thirds is it? Oh, I don't want to do that. So what do? I go over to math, and I that's this button right here, and I frac it. So I math frac it. Well, bam, it's 64 over 3. 64 over 3 is one of the answers on my multiple choice test. I circle it, and I move on. This is the most efficient way to do this if you have a calculator. So we got that one. Let's move on to the next question. Okay, this one is a little bit different. I'm going to show you how to use absolute values instead of top minus bottom. And I'm also going to show you how to store intersections / bounds in the calculator and use them in the most efficient way. So here I want you to find the area, and this is important. I said bounded instead of between. It's a little bit better way to say it, and it's more important in this one, by the two graphs y equals 2x and x cubed. So I'm going to enter those in. Okay, there we go. I got 2x in y1 and x cubed in y2. Hopefully you have the same. So again, I'm going to start with my zoom 6. I like doing the zoom 6. You can see in this one, it's not the greatest picture. I got this guy over here and this over here, and there's all this open space. So I'm going to show you another trick. I can do what's called a zoom box. It's zoom 1. With a zoom box, I define the corners of a new rectangle that will be the new window. So I'm going to do is make sure I get everything. This is going to be the bottom left corner. I scroll over and I hit enter. And now I'm going to scroll right to there and up to there. And now when I hit enter here, it's going that rectangle there is going to be my new window. So watch, bam, here it comes, here it comes. And now I can see that graph a lot better. So what I need to do now is calculate this intersection and this intersection. But notice I've got the red is the top and the blue is the bottom, and then it switches from here to here. So instead of doing, one way to do this would be to do the integral of red minus blue from here to what looks like 0, and then do another integral from blue to red from 0 out to here. Because of the symmetry of this graph, if I were to just do the integral of red minus blue, right, this minus that, which is top minus bottom here, from here out to there, then it would give me 0. All this area would flip and would be positive, and then this would be negative, and they would cancel each other out. So, take a look here. If I do red minus blue here, R minus B, I get a positive value. If I do red minus blue here, I get a negative value. So what I'm going to do is make it, but you should see that if I were to negate this value right here of red minus blue, I would get a positive version that is what I want when I take the top minus the bottom. So when I do this integral, what I'm going to do is do the integral, I'll get the bounds in a moment, of the absolute value of y1 minus y2 dx. If I do that, then it'll take care of the top and the bottom, and I don't have to flip-flop and flip it into two different integrals. And the calculator can actually do that calculation pretty quickly for me. Hopefully that makes sense. And now I'm going to talk about how to do the bounds. And I'll call this y1 and y2. So let's flip over here. So to get the bounds, look, this is 1. I can't see 2 in there. You can see it's a decimal there. You could solve for it algebraically if you wanted to. But instead, I'm going to calculate. I'm going to do second calc. Intersect is number 5. First curve, blue. Second curve, red. And then I'm going to scroll over to here so that I'm close to that. And I'm going to hit enter. All right, so there's the intersection, negative 1.414, blah, 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 blah. So in the AP, I need to carry my decimals until the very end, especially when I'm using a calculator. So I can't round that number. So I'm going to quit. I'm going to clear this out. Watch what happens. Look at that number here. Oh, it's gone. It was 1.414 something. Watch what happens if I hit X and hit enter. It pulls up that number. That number is stored in my calculator as X currently. Same thing for Y. If I were to pull up Y, it would give me that Y coordinate. So that is going to be my starting bound. So what I can do is store that thing, that's this button down here, and choose alpha A. Enter. And now I can go back to my, whoops, not second. I can go back into my graph, and I can do second calc. Intersect is 5, and now I can scroll all the way over. You know, I could hit the number, but whatever. For bam. All right, I got blue, I got red, I got my guess. Bam. Notice it's a positive version of that thing. So what I can do now is go and pull up X again, and hit store, and hit alpha, and hit B. Enter. So now these two numbers, this A and this B, are the values that I'm looking for. So let me flip back to here. What do I want to do? I want to use A and I want to use B. If this was a FRQ on the AP, I would want to identify what those are. But for now, we're just going to go ahead and write A and B. And I am going to use my Math 9. So I'm going to Math 9, my starting value is alpha A, my ending value is alpha B, and then I want to pull up the absolute value. That is in Math over in Num, and it's the first option, ABS. I pull that up, I get some absolute value bars, and now I'm going to use my alpha trace y1 minus alpha trace y2 dx. And now I'm going to hit enter. And it super fast gives me that area equal to 2. So hopefully this one makes sense as well. It's kind of nice that like we have these like terrible decimals and then it gives me this 2. You could work it out. But running out of time. Let's flip back here. That guy is just equal to 2. So hopefully you see how to use absolute values instead of the top minus bottom, and you see how to store intersections and bounds and use them as bounds with this A and this B. And you also see how to use that math frac and figure out what the top is and what the bottom is. In the next video, I will do this one right here, which is I'm going to integrate with respect to a variable other than x.